All right, welcome to This Explainer. I'm genuinely thrilled you're here today because we are embarking on a journey that is, frankly, unlike any other. We're going to look at the ultimate fate of the universe. What does the deep future actually hold? To even begin to grasp the staggering scale of what we're talking about, we're going to have to travel exponentially through time. Imagine doubling our speed into the future every 5 seconds. We're going to zoom past the end of our Earth, past the death of our sun, and right up to the literal end of time itself. But, before we get completely lost in the sheer, almost unimaginable vastness of trillions of years, I want to anchor us with this beautiful thought from Helen Keller. She said, "Everything has its wonders, even darkness and silence." As we venture into the deep, dark future of the cosmos, it can feel a little overwhelming, right? Maybe even a bit existential. But I promise you, there's a profound, almost poetic beauty in the darkness and silence of the deep future we're about to explore. Okay, let's dive into this. How will the universe actually meet its end? Now, we may never be 100% certain, but we're finally starting to piece together a stunning, almost unbelievable picture of how the future might unfold. And to really understand the end, we first have to realize that on a cosmic scale, our universe has only just begun. So, era number one, the fading window of life. Let's see how the universe evolves. As we accelerate forward, the familiar cosmos we know and love today is going to change, and it's going to change incredibly fast. Everything on our planet and up in our night sky is constantly in motion. Looking out from our present day, the Earth will undergo some pretty drastic changes. Magnetic fields flip, sea levels rise, and eventually, as our sun starts running out of fuel, its luminosity is going to spike. The Earth's oceans will just evaporate, and all life will cease. And the sun won't just quietly fade away either. Its core will collapse, and the extra heat will cause its outer layers to balloon into a massive red giant, ultimately destroying the Earth. Finally, the sun will shrink down into a white dwarf, a dead, cooling remnant. And this is the fate for all stars. The universe will end not with a bang, but with a whimper, and not in fire, but in ice. Now, what's really interesting about this slide is this number, 10 to the negative 84th percent. It is an absolutely impossibly small number. So what does it actually mean? Well, the arrow of time creates this bright little window in the universe's adolescence where life is actually possible. But if you measure the entire lifespan of the universe, from its very beginning all the way to the evaporation of the last black hole, life as we know it is only possible for 1,000th of a billion, 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 billionth of a percent of that time. It's a haven in time, and it definitely doesn't stay open for long. Moving on to era number two, the age of zombie stars, also known as the degenerate era. In this era, the age of starlight comes to a complete end. The universe slowly transforms into a kind of cosmic boneyard, literally strewn with the remnants of dead stars. And the primary inhabitants of this era are white dwarfs. Think of a white dwarf as a hot, dense, shrunken stellar corpse. Since it has no fuel left to burn, its faint glow comes solely from the residual heat of its extinguished furnace. To put it in perspective, if you were to look at one from where Earth is now, it would only generate about the same amount of light as a full moon on a clear night. As the universe drops in temperature, these faint corpses will provide the absolute only illumination in a totally dark, empty void. It's incredibly eerie when you think about it. It's a ghost universe. Star creation stops entirely. Gravity just starts ejecting dead stars and rogue planets out into the freezing void. Every now and then, by sheer chance, brown dwarfs might collide to form an accidental new star, or colliding neutron stars might puncture the dark with a sudden supernova. But mostly, it's just silent. If any conscious life forms somehow manage to survive and seek refuge around these aging white dwarfs, they'd have to adapt drastically. I mean, they might have a completely different pace of life, a living system where having just one thought every 10 trillion years would seem perfectly normal. But eventually, even those white dwarfs fade and die, becoming black dwarfs. These are the true ashes of stars. The atoms inside them are so severely crushed that a single black dwarf is 1,000,000 times denser than our sun. They emit barely any heat or light at all. In fact, stars take so incredibly long to cool down to this point that scientists believe there isn't a single black dwarf in existence in our entire universe right now. Which brings us to era number three, the black hole era. This is where atoms begin to decay. Current theories predict that eventually atoms themselves will just begin to decay. The protons, literally the fundamental building blocks of you, me, and everything we see around us, will just spontaneously fall apart. Any matter that hasn't already been sucked into a black hole will simply disintegrate. And this brilliantly illustrates what happens next. When all regular matter is gone, supermassive black holes become the new fundamental building blocks of the universe. We'll have zombie galaxies made entirely of black holes orbiting even larger black holes. And trust me, it is not peaceful. These black holes will merge, growing to enormous sizes, trillions of times the mass of our sun. When they cross thousands of kilometers in a fraction of a second to collide, they send out these powerful gravitational waves. They squeeze and stretch space, wringing space-time literally like mallets on a drum. So the universe remains incredibly violent and dynamic. It's just operating on timescales of trillions upon trillions of years. But it turns out, even black holes aren't immortal. Over quadrillions of years, they evaporate through something called Hawking radiation. It's a bit of a mind-bending quantum concept, but here's how it generally works. Step 1. Empty space is actually filled with virtual particles and antiparticles constantly popping into existence in pairs, and then immediately annihilating each other. Step 2. If this happens right on the absolute edge of a black hole, one of those particles might fall in. Step 3, its forsaken partner is left without anything to annihilate with, so it actually escapes out into the void as radiation. And step 4, over unimaginable timeframes, this process causes the black hole to slowly leak mass until it evaporates completely, vanishing in a gigantic explosion. So quantum mechanics literally allows particles to escape the ultimate cosmic prison. All right, era number 4, dark energy and escape. Welcome to the expanding void. As these black holes slowly die off, lighting up the darkness one by one, the universe itself just continues to expand. And this brings us to the mysterious force dictating our ultimate end, dark energy. See, the universe isn't just expanding, it's speeding up. It's expanding completely out of control. Dark energy makes up nearly 75% of the matter-energy content of the universe. It resides in empty space itself, exerting this massive outward push. And here is the truly terrifying part. Unlike regular matter or radiation, dark energy does not dilute as the universe gets bigger. It just keeps pushing. This has absolutely enormous implications for our final fate. Discovering the true nature of dark energy could change our vision entirely. On one hand, if dark energy somehow weakens over time, gravity could actually win out, pulling everything back together in a big crunch. On the other extreme, if dark energy gets a sudden boost, it could accelerate so violently that it literally tears atoms and the very fabric of space-time itself apart in a big rip. However, based on our current understanding, the forecast suggests neither of those. Instead, we're heading toward a runaway, ever colder, ever emptier universe. So the crucial point is, does this end have to be the end? Some physicists speculate that facing the death of absolutely everything, highly advanced, intelligent life might actually find a way to escape. They might use tremendous energy from cosmic atom smashers to open gateways to baby universes, acting as sort of cosmic lifeboats. This leads to this fascinating, incredibly awe-inspiring idea of a multiverse, where a sort of cosmic evolution takes place. Universes that harbor intelligent life create baby universes and proliferate, while infertile universes without life simply die out. So the death of our universe might just be a catalyst for survival and new beginnings elsewhere. And finally, era number 5, time becomes meaningless. The absolute end. If there is no escape, entropy will just continue its march. We finally arrive at the absolute end of the timeline. The very last supermassive black holes will explode and die, bathing the universe in light one last magnificent time. After an unimaginable length of time, the cosmos is reduced to nothing but a vast, empty sea of photons, gradually cooling toward absolute zero. The absolute last remnants of dead stars have decayed away to nothing. The entire universe reaches the exact same temperature. And because the cosmos literally cannot get any more disordered, entropy finally stops increasing. For the first time in its entire existence, the universe is permanent, unchanging. Time itself becomes completely meaningless. Once entropy maxes out, the story of the cosmos is entirely over. Nothing happens, and it keeps not happening forever. It's a pretty heavy thought, isn't it? To bring this all back down to earth, let's look at the second half of that Helen Keller quote. And I learn, whatever state I may be in, therein to be content. Against the backdrop of a freezing, infinite eternity, our brief 10 to the negative 84th% window of life is a spectacular miracle. It really begs the question, what does our brief, incredibly rare window of life mean to you, knowing the infinite silence that waits at the end of time? Thank you so much for exploring the cosmos with me today on this explainer. Keep learning, keep wondering, and I'll see you next time.